Let me consider a simple example for a convolution sum. Okay, so let us try to find out the convolution of delta of n with a simple signal, basic signal. Let me take u of n just for the purpose of understanding. Okay, so del of n convolved with the u of n. Now what is the result for this? Now as I said, what is the first step? Change the independent variable to another variable. Say del of n becomes del of k, then u of n, you write it as u of k. That is the first step. What is the second step? Fold any one. Let me fold del of n. So del of minus k. Then third step is shift by n units, del of n minus k. Here let me consider n less than 0 and n greater than 0, two cases. And then fourth step is multiply this shifted impulse by the input u of n. So u of n times del of n minus k. And the fifth step is sum them up. That's all. So these are the basic steps. So your u of k will be like this. This is u of n. If you draw it in the independent variable k, 0, 1, 2, 3, 0, 1, 2, 3 like that. This is u of k. Just I changed the variable. Okay, independent variable. Now what is del of n? Del of n is sitting like this. Del of n equals 0. Now draw it in the k like this. This is k. Now del of minus k also the same, no change. Okay, so because it is an even function. Now shift by n units. When n is negative, then it is sitting somewhere else. This is del of n minus k, where n is less than 0. This point is 0, minus 1 dot dot dot, let's say n, and this n is negative. If you draw the same point somewhere else, then this also n, but here this n is positive. This is k. Okay, and this is again n minus k shifted in the right, but this n is positive and this n is negative. That's it. So second step is over. Not second, third step also over. Fourth step you need to multiply. Now this is your u of k, and this is your del of n minus k, where n is negative. Now multiply term by term, you will get 0. Therefore the output y of n, which is del of n convolved with u of n, is equal to 0 when n is less than 0. Even if you take n equals minus 1, then what will happen? The pulse will come here. This is del of 1 minus k. 1 minus k. Here this is minus 1 sitting at this point is 0. Then also if you multiply u of k with the del of n minus 1, del of 1 minus k, again you will get 0 term by term. If you multiply, here the value is 0 and here this is non-zero. This is 0, this is non-zero 1, and this all are 0, but here all are 1, and here all are zeros. Now let us consider n is equal to n is equal to 1, then what happens? Your impulse is exactly sitting at the origin, del of k. This is 0, 1, 2 and so on. Now what is output? In this case, u of k times del of k. The output is 1. Why? Because here the amplitude is 1 and here also the amplitude is 1. Therefore it is 1. And here it is 0 and here this all are zeros. Therefore if you make summation of u of k times del of k, where k is equal to minus infinity to plus infinity, only one place it is non-zero, so therefore it is 1. Now substitute n is equal to 2. Then what happens? Sorry, n is equal to 1. N is equal to, sorry, 1 minute. This is not n equal to 1, this is n is equal to 0. I am sorry. Okay, when n equal to 0, then this becomes like this. N minus k, 0 minus k, del of n minus k, which is del of 0 minus k, which is in fact when I don't know why I am making mistake. Let me explain this again. So I am sorry, I did some mistake. Up to this okay. Up to this point okay, del of 1 minus k. Now let us assume n is equal to 0. So in that case your delta function is sitting exactly at here, del of minus k, right? Now you multiply u of k and del of minus k. Now term by term, see, here the value is 1 and here the value is 1. So 1 times 1, 1. It is equal to 1. Therefore your y of n is equal to, rest of all the places it is 0. Why? See, here I have 0, here I have 1, here at n equals 1, 2, 3, 4, this is k. So here it is 0 and here it is 1, here it is 0 and here it is 1. So there is no overlap actually. Okay, 1 is multiplied by 0 or 0 is multiplied by 1. So like this, here 0 and here 1, here 1, here it is 0, like that. Therefore this product becomes 1. So your output, in fact you can put the summation like k is equal to minus infinity to plus infinity u of k del of minus k times, which is equal to 1. Fine. Now let's take n is equal to 1. In this case what happens? Your u of k is like this, 0, 1, 2, 3, 4, like that. This is your u of k. Then your impulse is sitting at 1. This is k and this is del of 1 minus k. This point is 1 and this point is 0. Multiply u of k and del of n minus k, term by term you multiply. What will happen? At only one places the multiplication gives non-zero. This point and this point, and here it is 0 and here it is 1, multiplication leads to 0, and here it is 0 and here it is 1, here it is 1 and here it is 0, likewise. Therefore again this is equal to 1. Therefore your here y of 0 is equal to 1, here y of 1 is equal to 1. Similarly, we substitute n is equal to 2, this is n equal to 1. Again, then also y of 2 becomes 1, n equals 3, y of 3 equals 1, and so on so forth. This calculation continues. So finally what you can say is delta n convolved with the u of n is equal to y of n. This y of 1 is the same as the input u of n, no change. Why? Because from this y of n is equal to 1 for n greater than 0 and 0 elsewhere. So, don't you see that this is precisely the definition of what? Definition of u of t. Therefore, the input is u of t convolved with del of n. Again you are getting u of n at the output. Therefore, you take any arbitrary sequence x of n, you convolve with del of n, again the output is going to be the same input, no change. So, that is the thing I wanted to prove from this example. Okay. So, you take any arbitrary sequence, convolve with del of n, and the output is the same arbitrary sequence. Now, instead of if I have x of n convolved with del of n minus n naught, then apply the same time shifting property, the output becomes x of n minus n naught. Or you take x of n minus some number x n naught convolved with del of n minus n naught, then it leads to, like this, x of n naught. Or you may have like this, x of n minus n naught convolved with del of again n of n minus n naught. So, this will becomes x of n minus 2 n naught. The argument is added, this one and this one. Now, sometimes people will say x of n plus n naught convolved with del of n plus n naught. Then in this case it is x of n as it is. No, one, let us take one is minus n naught like this. Now, x of n plus n naught convolved with the del of n plus n naught gives rise to x of n plus 2 n naught. Like that it keep on goes. Okay. So, these are some important corollary of impulse functions. The same thing applicable to this also. Let us take, suppose if you convolve del of n with del of n, what will you get? Again you will get del of n. Or del of n minus 1 convolved with del of n, then you will get del of n minus 1. This minus comes there. Del of n minus 1 convolved with del of n minus 1, it becomes del of n minus 2. Sometimes let us say del of n minus 1 convolved with del of n plus 1. This minus 1 and this plus 1 will get cancelled, you will get del of n. So, these are only the arguments are added, that is it, not independent variable, the shift. So, these are some important properties, please note it down. Okay. So, let me stop at this point.